Hello, students, and welcome to our lesson on inverse relationships, inverse variation. We will start with our do now as usual. This one is about group dynamics. We will explore our objective, which is inverse variation. Our essential questions ask, what is an inverse relationship? What is the constant of variation in an inverse relationship, and how can I identify the graphs of inverse variation equations? As we watch the video, we have 4 assigned pages. 2 of those pages are graphs. For our exit ticket, we will complete these 2 thoughts. An inverse variation is a specific relationship in which there is a constant what, and inverse variation equations are written in what form? We have a homework, inverse variation. There are 19 problems. And reminder, this week you will turn in your lessons and your homeworks all on Friday. So the important notes, as always, let's get those cameras on, respond when your name is called, submit your lessons all on Friday this week. And if you have any questions, the way to get a hold of me is by email. Also, let's remember that Friday is Superhero Day, so represent a real or fictional superhero in your life. It could not just be something you wear, maybe it's an object that you have next to you while you work to kind of mindfully remind you of that person who's really important, even if it's a fictional person. Friday, we have our quiz on direct and inverse variation. Doing your homework and your lessons ahead of time will be highly beneficial. So please heed that advice. And there's our Spirit Day reminders. And our do now is about group dynamics. What is group dynamics? Well, group dynamics refers to the behaviors and processes that occur when we're in a group. So, sort of our interactions with each other. So, how has the COVID-19 pandemic altered the group dynamic of the classroom? We know we're not working on projects this year. We're not doing as much kind of hands-on artsy stuff. But what about the group dynamic? What about working together or learning from each other or just getting to know each other? How has that changed in the group in the COVID-19 pandemic? And I encourage you to write a couple of thoughts just below that do now. And please do that. We'll get back to our exit ticket in a minute. But meanwhile, let's get started on our lesson. Our topic today is inverse variation. Okay. So, an inverse variation is a specific relationship in which there is a constant product. Product is the answer we get when we multiply, and that product is x times y. Constant product between two variables. Constant product, it does not change. It's consistent. The constant of variation is the variable k. Inverse variation equations are written in the form of y equals k divided by x. And we will look at those graphs in a minute. But for now, let's find the constant of variation. Let's find k. So we're going to identify the constant in the ordered pairs below. Then we'll write an inverse variation relationship or equation to represent that relationship. So when we look at these ordered pairs, 1, 20, 2, 10, 4, 5, okay, what happens when I multiply them together? Because remember, it's a constant product of x times y. So if I multiply 1 times 20 and multiply 2 times 10, if I multiply 4 times 5, in all cases, we will have 20. So our constant is 20. So we will write the equation y equals 20 over x. Remember, because our inverse variation equation is y equals k divided by x. So y equals 20 divided by x. So let's check out the next ones. Inverse variation is in many ways much easier. So we have 1 times negative 28, 2 times negative 14, 4 times negative 7, and in each case, they will all equal negative 28. So our constant of variation is negative 28, and our equation is y equals negative 28 over x. So go ahead and try 3, 4, 5, and 6, and let's compare answers in a minute. Okay, so number 3, let's choose an ordered pair. I'll choose the first one. K equals negative 8 times negative 6.5, which equals negative 52. So y equals negative 52 over x. That's simple. Number 4, k equals 3 times negative 9, which is negative 27. So our inverse variation equation is y equals negative 27 over x. Now, just because we've got it in a table, number 5 and 6 doesn't change anything. We've used tables before. So we've got, we can choose an ordered pair. I'll choose the first pair. So our k will equal negative 5 times 2.4, which equals negative 12. And our inverse variation equation, y equals negative 12 over x. And number 6, and you could choose any pair. You could have chosen negative 3 times 4, which might have been easier, or negative 2 times 6. So I'm just going to go ahead and choose the first pair. K equals negative 0.5 times negative 12. So our answer is going to be positive. A negative times a negative is a positive, and it will equal a positive 6. Our inverse variation equation is y equals 6 divided by x. Now, in the next 4, we're going to identify the equations. We're going to determine whether each equation represents an inverse variation. So it's going to be yes or no. But if it is yes, we will identify the constant of variation. So y equals 50 over x. And if we just look at it, it is in the form, just like the last couple of problems we did, it is in the form of an inverse variation equation. So the answer is yes. And the constant of variation, the k, equals 50. Now, in number 8, we have y equals 3 times x. Okay, not in the correct form. So the answer is no. End of story. Number 9, we have xy equals negative 14. Well, let's go ahead and solve that for y. So xy equals negative 14. Divide both sides by x. And we have y equals negative 14 over x. Yes, that is an inverse variation relationship. And our k, our constant of variation, equals negative 14. And number 10, we have y divided by x. There's no way we can solve for y and get negative 6 over x, or is there? Well, let's solve for y. The way we solve for y is we multiply both sides by x. And when we do that, we have y equals negative 6x. Nope, not an inverse relationship. So far so good. I hope you're with me. We've got 4 more just like this. Why don't you go ahead and try them and then come back to me and see how you did. So in number 11, I will solve for y, I will divide both sides by 2x. And when I do, I have y equals negative 40 divided by 2 is negative 20 over x. And the answer is yes. And our constant of variation is negative 20. And let's solve for y in number 12. We'll divide both sides by 7, which gives us y equals 28x over 7, which reduces to y equals 4x, because 28 divided by 7 is 4. Still not an inverse variation relationship. In number 13, we have a proportion, right? Remember how to solve these? Use cross products. So 9 times 8 equals x times y. So we'll have 72 equals xy. Divide both sides by x so that we identify y. And we end up with y equals 72 over x. And yes, that is an inverse variation equation, and our constant of variation equals 72. And finally, number 14, we are going to divide both sides by negative 4. And when we do that, we end up with 4. I'm sorry, y. I should have written y there, not 4. We end up with y equals, so 20 divided by negative 4 is negative 5 over x. And yes, that is an inverse variation equation, and our k in this case equals negative 5. So now we're going to find missing values, and we're going to use our old friend, the proportion, in a sense. We know, let's go back to the beginning, that an inverse variation is a specific relationship in which there is a constant product between two variables. So we're looking to multiply the variables. We have in front of us 2 points, 12, 14, and negative 24y. So the constant product between these two sets of ordered pairs should be the same. So the only way to figure out what that is to solve for y. So 12 times 14 should equal negative 24 times y. 12 times 14 is 168, which equals negative 24y. And we divide both sides by negative 24. And y equals negative 7. So we've got the missing value. So what we would end up with is the first point, 12, 14, and the second point would be negative 24, negative 7. And if we multiply 12 times 14, we get 168. If we multiply negative 24 times negative 7, we'd also get 168. So we have that constant product represented. So number 16, 6 times negative 10 should equal 3y. So negative 60 equals 3y. Divide both sides by 3, and y equals negative 20. Super easy. Let's box our answers. And why don't you try 17 through 22 and come back. Okay, I hope you did them on your own. I'll do them now. I bet you did very well. So we have 9 times y, which is 9y, equals negative 18 times 6. That would be 9y equals negative 108. Divide both sides by 9. And y equals negative 12. And that's the missing value. Number 18, we have x times negative 7 equals 21 times negative 3. So that would be negative 7x. We usually write the coefficient before the variable, equals negative 63. We'll divide both sides by negative 7, and x equals 9, because negative 63 divided by negative 7 equals a positive 9. And number 9. Be very careful when you read these. If y equals 9 when x equals negative 6, take a moment and write down that ordered pair so you don't get confused when you do the problem. Find x, so we don't know what x is, when y equals 3. So negative 6 times 9 equals x times 3. So negative 6 times 9 is negative 54 equals 3x. Divide both sides by 3. And x equals negative 18. Number 20. If y equals 16 when x is negative 3, find x when y equals negative 6. So we have negative 3 times 16 equals x times negative 6. So negative 3 times 16 is negative 48 equals negative 6x. Divide both sides by negative 6 to isolate x. And x equals positive 8, because negative 48 divided by negative 6 is positive 8. So the last two problems on this page, remember we're going to be doing some graphing after this. If y equals 12 when x equals negative 6, find x when y equals negative 24. So we have negative 6 times 12 equals x times negative 24. So negative 6 times 12 is negative 72, and that will equal negative 24x. We'll divide both sides by negative 24, and x equals 3. And number 22, if y equals negative 8 when x equals negative 7, find y this time. So they're giving us x is negative 4. We're asked to find y. So negative 7 times negative 8 equals negative 4y. Negative 7 times negative 8 is a positive 56 equals negative 4y, and we divide both sides by negative 4, and y equals negative 14, because positive 56 divided by negative 4 is negative 14. So now let's work on the graphing. So let me tell you how we graph these inverse variation equations. We're told that k equals 16. So let's figure out some values. Remember, our equation will be y equals 16 over x. So we'll make a table of values that equal 16 when multiplied together. So let me change the color, and let's see, we multiply 16 together. We can do 1 times 16, 2 times 8, 4 times 4, 8 times 2, or 16 times 1. But let's not forget, we can also get to 16 by multiplying together two negatives. So let's do the negative values that multiply together to positive 16. So negative 1, negative 16, negative 2 times negative 8, negative 4 times negative 4, negative 8 times negative 2, and negative 16 times negative 1. Now we go ahead and we plot those points. So 116, some of them we might not be able to fit on the graph. So I'm going to count each one of these as 2. So 2, 4, 6, 8, 10, 12, 14, 16, and I'm going to do the same thing with the y-axis as well. So that would mean positive 1, 16, 2, 4, 6, 8, 10, 12, 14, 16. Positive 2, 8. 4, 4. 8, 2. And 16, 1. Now take a look at this curve. And let's put our arrows on the end. Now let's plot the rest of it. We've got negative 1, 16, negative 2, 8, negative, I think I made a mistake with that point. Remember, we're counting by 2's on the x and y axis. So negative 2, 2, 4, 6, 8, negative 4, 4, negative 8, 2, negative 16, 1. Okay, and here's the other line that makes up this graph. Okay, that is the graph, a direct variation graph for positive numbers. Now let's do another one. Remember, we're looking for products that equal 24 because y equals 24x. So x and y, how do we get to 24? We're going to have our positive and our negative. And we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 6 times 4, 8 times 3, 12 times 2, and 24 times 1. On the negative side, we have negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, negative 4 times negative 6, negative 6 times negative 4, negative 8 times negative 3, negative 12 times negative 2, and negative 24 times negative 1. So instead of plotting all these points, I've actually gone ahead and I've graphed this in Desmos. So let me turn off some of the other ones we're not looking at right now. And this is the graph, the black lines, the graph of y equals 24 divided by x. So it's similar to the graph we just did, which is y equals 16x. That's the purple graph that I just put up there. So we have the first two graphs that we just did are there. So let's go back and let's finish our work. I'm not going to draw them because I showed them to you on Desmos, but generally you'll see that they kind of go like this. Generally, this is not exact. We have Desmos for that. So now we have k equals negative 36, and we're going to see something a little different in our graph. So first we make our chart of x and y values, and we're going to have our negative x and y values as well. Now we need to multiply to negative 36. So that would be a positive 1 and a negative 36. Let's make all the x's positive and all the y's negative. Positive 2 and negative 18, positive 3 and negative 12, positive 4 and negative 9, positive 6 and negative 6, positive 9 and negative 4, positive 12 and negative 3, positive 18 and negative 2, and positive 36 and negative 1. Now we do the opposite on the other side. Negative 1, positive 36, negative 2, positive 18, negative 3, positive 12, negative 4, positive 9. Negative 6 times 6, negative 9 times positive 4, negative 12 times positive 3, negative 18 times positive 2, and negative 36 times positive 1. So how do you think the graph is going to differ when we're looking at k equals negative 36? Remember, that is y equals negative 36 over x. Let's take a look at Desmos. We did graph it. I'll turn the other two graphs off. And here is our y equals negative 36 over x. I'll turn the first graph back on so you can compare. So if we look at the purple graph, you see it's in the upper right and lower left quadrants, but the negative 36 over x is in the upper left and lower right quadrants. So the quadrants have changed. So you could probably make some predictions about these next two, y equals negative 60x and y equals negative 48x. But let's go ahead and work on those. So going to the next page, why don't you try these next two yourself and actually pull up Desmos and try to work on them. Okay, so we're going to make our two tables for our x and y values. And we're going to have an equation of y equals negative 60x. Okay, so we've got negative 1 times positive 60, and that would be 1 times negative 60. We've got negative 2 times positive 30, or positive 2 times negative 30. We've got negative 3 times 20, positive 20, or positive 3 times negative 20. We've got negative 4 times 15, or positive 4 times negative 15. We have negative 5 times 12, or positive 5 times negative 12. We have negative 6 times 10, or positive 6 times negative 10. We have negative 10 times a positive 6, or we can make that 10 times negative 6. We have negative 12 times positive 5, or positive 12 times negative 5. We have negative 15 times positive 4. Negative 15 times positive 4 is negative 60. So that would be a positive 15 times a negative 4. We have negative 20 times 3, or 20 times negative 3. We have negative 30 times 2, or 30 times negative 2. And we have negative 60 times 1, or positive 60 times negative 1. So let's make some predictions about that graph. It seems to me that the graphs that are negative will occupy the upper left and lower right quadrants. Now that is not an exact representation. That's why we have Desmos. And let's turn on the graph of y equals negative 60x. It's the blue one. And indeed, if you predicted that as well, there's your answer. Good job. So our final graph that we have to plot is k equals negative 48. So we have our x and y values. So that would be negative 1 times 48, or 1 times negative 48, negative 2 times 24, or positive 2 times negative 24, negative 3 times 16, or positive 3 times negative 16, negative 4 times 12, or positive 4 times negative 12, negative 6 times 8, or 6 times negative 8, negative 8 times 6, or 8 times negative 6, negative 12 times 4, or 12 times negative 4, negative 16 times 3, or 16 times negative 3, negative 24 times 2, or positive 24 times negative 2, and negative 48 times 1, or 48 times negative 1. So if our predictions so far led us to believe that negative inverse variation equations end up in the upper left and lower right quadrants, then that should be what we find with this one. We should find something that looks similar to this. So let's go to Desmos and turn on that graph, y equals negative 48x, and indeed, all of the inverse variation graphs that have a negative constant of variation occupy the upper left and lower right quadrants of the Cartesian plane. So we're almost done. Let's get back to our paper. We're asked to write an inverse equation to represent the relationship shown on the graph. So we're writing the equation from the graph this time. So all we need to do is look at a couple of points and plot them. And if I look at this carefully, I do see negative 6, negative 2 is a point. Always find points that lie exactly on the intersection of the grid marks. I also see that point 2, 6. Remember, each one of these is in increments of 2. So 2, 6 is also a point. So let's just multiply. I think I miswrote that. That should be a negative 2 right here. That is negative 6, negative 2 right there. So let's multiply. K equals negative 6 times negative 2, which equals 12. And we see in the other set of ordered pairs that 6 times 2 is 12. So therefore, y equals 12 over x. This is a graph of y equals 12 over x. And finally, number 7, let's choose some ordered pairs. I do see we have the point 8, negative 8, 4. We also have the point 4, negative 8. 1, 2, 3, 4, negative 8 right there. And either way, k equals negative 8 times 4, which is negative 32. So our inverse variation equation would be y equals negative 32 over x. And if one last thing, we graph those on Desmos. we would see, I can't do it because I separated my keyboard. I'm sorry, students. You can do it on Desmos, though. If we graphed y equals 12 divided by x and y equals negative 32 divided by x, we would see graphs that look similar to what is here on your paper. So let's get back to our exit ticket. An inverse variation is a specific relationship in which there is a constant product. Product is the answer you get when you multiply, and it's a product of x times y. That's why we multiplied those values in the ordered pairs. And inverse variation equations are written in the form y equals k divided by x. So that's inverse variation. I hope you enjoyed the graphs, and I hope you will work hard, and I know you already have, but as you continue to work hard, you really build your algebra muscle, and then you'll be, as far as algebra goes, you'll be really great.